So we'll be starting in 5 minutes. We'll start the next session in 5 minutes. So everyone, please join.
Uh, Jiten sir, have you joined, sir? Okay. So our resource persons have joined. Good afternoon, Jiten sir. So Doctor, I am going to introduce about him. Dr. Jiten Kumar is the Associate Professor of Statistics and Statistical Computing in Department of Mathematics, School of Advanced Sciences, Vellore Institute of Technology, Vellore, Tamil Nadu, India. He is having over 25 years of professional work experience ranging from industry to research and academics. He had served over 5 years to some well known corporate industries, namely Proficiency Technology, Gurugram, DataNet India Private Limited, New Delhi, CSC Private Limited, New Delhi, Bioinformatics Institute of India, Noida, Caslet Pharmaceutical Private Limited, Bhiwadi, Rajasthan, and some other establishment too as consultant, technical analyst, and statistician. He had served MET Noida for 13 years, from Jan 2006 to November 2018, including MET University Dubai campus. Formerly, he was a HOD Department of Statistics at MET Noida campus and had established the Department of Statistics. There has been flourishing even today. Dr. Kumar has been actively rendering his stochastic services and continuously suing for putting his best efforts towards his goal of the institutional growth in general and Department of Mathematics, SAS in particularly since November 2018. He had played a vital role in establishment and growth of the programs like MSc Data Science, MSc Business Statistics, MSc Computational Statistics and Analytics, 5-year integrated program, and has been significantly contributed towards the development of VIT, online MSc Data Science, and other programs. His core research areas are the following: mathematical statistics, computational intelligence, data science, statistical methods inferences, time series, modeling, CSE, AI/ML, deep learning. Dr. Kumar has authored and co-authored few books. He has guided over 500 dissertation, master thesis, and he has done so many things. And so, thank you, sir, and hand it over to you, sir. Please, sir, you may proceed, sir. Jiten, sir, is he muted? Jiten, sir, your voice is not audible. Jiten sir, your voice is not audible. Please, your voice is not audible, sir. Jiten sir, your voice is not audible.
Am I audible, sir?
Yes, sir, audible, sir, audible.
Oh,
Actually,
thank you.
voice was not audible.
Okay, now it's okay
Please,
now.
yeah, it's okay, sir. Okay.
Thank
You
you.
are
Thank you so much.
okay.
Okay, sorry for disruptions. It's a technical fault. Good afternoon, all, one and all. Myself, Dr. Jitendra Kumar. Thank you so much, Professor Dilip Kumar Chaube, sir. Let me at the outset express my sincere thanks to you, the coordinator, and most important, the director, Triple IT Bhagalpur, for giving this opportunity to have interaction with this worthy audience. I hope the audience may come from different backgrounds. Many of you may be the faculty members, research scholars, probably UG and PG students in across the country. I hope the session is going to be an informative session. I witnessed the previous session for last 1 or 2 days is full of information and practical sessions, and that is the best part of this program. The title of this program is a short-term training program on machine learning and deep learning in agriculture and biomedical engineering in a hybrid mode. Under this, my subtopic is application of multivariate time series analysis and modeling to agricultural productivity and growth in Indian scenario. So my talk is focused on few things because all these titles are very vast, very generic, and a lot of things need to be covered. So let me focus on agriculture part, agriculture growth, agriculture research, agriculture statistics, and related discussions. Here, I would like to share that all these uh, modern applications like AI and related machine learning and then deep learning tools and techniques and statistics itself is the bedrocks of all these methodology. So one need to be very sound in a statistical applications, and here we need to have some basics but very clear understanding. So let me have a clarification that why we do modeling, any kind of modeling. And the modeling ensures a objective decision making, and that made our job very simple in final decision making process. And there is, perhaps all of you agree, that decision making itself is a process. It comes through different phases. The very first phase start with informations in a form of data, and that information could be in any form, maybe in a form of numeric, non-numeric, and other forms. Data scale needs to be at the beginning to any researcher who is handling data, maybe the nominal, ordinal, interval, ratio scales, and the clear concept of those scales required. Otherwise, what happened? A wrong data scale could lead to wrong tools, and finally, your all efforts of modern applications will go wastage. So one should be very clear on data scale and variable selection. Then the next steps comes comparison. Means once you know the data and their characterization, whether it is a univariate data or it is a bivariate data or it is a multivariate data, you have to compare themselves. And once you compare, there is a requirement of variable interrelationship, and those relationship PPT abhi is yet not started. I am going to share the PPT in my own way, in my own notes. So just in the background, I am giving you this. Then I am going to share my hand notes, and accordingly we'll go to that. Because usually I do not use PPT. I rely on my own hand notes and own workability. So I'll not take you into in depth of any tools like going for coding, and which you have already done with online hand-on session. I'll go to make it interactive and informative in a very simple way on simple focus on variables. So a model requires, very first requirement of a model, whether it is a quantitative or qualitative or any type of model, is input variables, input information, and then there must be a output function, output variables. There must be a parameter, and then the fourth requirement is functional relationship between input and output, and the last, that every model must have certain constraints, certain laws, theorems, lemmas, initial condition. Let's say example, force is equal to mass into acceleration. Is it a model? Yes, it is a model because it fulfills all these four criteria of a model. There are many people who are doing the modeling without considering the elements of modeling, process of modeling, and whether it is a model or not. So I say you that here force is equal to mass into acceleration. Force is a output variable, acceleration is the input variable, mass is parameter. It is not every mass where this equation and this model work. This mass must be an inertial mass, and that must obey the Newton's first law. Then only we can say that force is equal to mass into acceleration is a model. Similarly, you can give n number of examples. For example, you go to probability distribution function. You take any distribution, let's say Poisson model. Probability of any event x is equal to e to power minus lambda, lambda to power x upon x factorial. Again, here lambda is a parameter, x is input variable, random variables that decides the events, and then probability of x will be computed based on that. And Poisson law is applicable to certain conditions, not to every condition. We cannot apply Poisson law to every event. And perhaps many of you know that when events are rarest of the rare, that means number of trial n is very large and probability of success p is very small, then we can apply Poisson model. Similarly, each of the model have to satisfy these four conditions. Now I am going to say you that I am through that you people are quite convinced with model and modeling process. Now, when I go to talk about agriculture productivity and growth, we do modeling, we do computing, we do the advanced experimental designing, and we do plotting. A lot of things. Agriculture is very vast. But what is the first point, first requirement for agriculture research, academic progress, and agriculture growth and development for policy research and all? There are innumerable variables in agriculture research. So allow me to go to discuss first on what are those variables and which variable need to be measured in your research to fulfill which task. For example, if you have a classification problem, what are the possible reasons, objectives, variables, parameters? So this is what I'm going to share small notes. This is the share. Just wait. Where is the option for sharing? This is what? Setting, report, useful problem, background, full screen adjust now. Dilip sir, have you permitted me for slide share options?
Yes, sir. You can share.
Oh,
Can you please check once?
okay. I'm trying. Just a minute.
Okay, sir. Yeah.
Select a tab to share. From window. Go to
The share option is present after the camera icon, actually. So,
okay. I got it, sir. I got it. I'm
sure,
doing it.
sure. Yes.
It's not clear now.
Yes, sir. Your screen is being shared. So please go to the slides or whichever part.
Okay. Just I'm finding this folder.
No, sir. So you have stopped sharing now. So
1 second. Just 1 minute. I'll go to desktop. Just 1 second. Hold on, please. Triple IT Bhagalpur. Okay. Then we'll go to here. Now we go to share the window, entire screen. Share. That folder is representing entire notations. It's not clear that side now.
sir, you are sharing your screen, so you can go to the slides wherever it is for you.
Okay.
The screen is visible to us.
Okay, fine.
Yeah.
I have opened the slide.
Yeah.
Then now it's coming, sir.
Yeah, it's coming, but can you please minimize this Google Meet?
Okay, sir. Just a minute. Is it okay now?
It can go a little. You can minimize it more if possible. You can minimize it more.
Okay, sir.
Yeah. So
Now
okay.
when
Yeah.
scrolling is okay.
Yeah. It's fine, sir. Yeah. Sure.
Fine. Thank you. Sorry
Thank you,
for
sir.
this. Sorry for this. So now we can see it. This is the start of the slides which I prepared. In fact, it's not a slide, it's my hand notes for this session. Here, this is the subtopic, and here I start with advanced methods and tools for agriculture statistics are evolving to handle large scale, high dimensional, and especially reference data, moving beyond basic analysis to predictive intelligence and modeling. Here, our main focus is to make you aware for every researcher, it is important to concentrate on variable selection, because if a wrong variable or dubious variable comes in the model, you cannot achieve what you want to do, because simply applying a advanced tool do not going to make meaningful output. There are many times people are showing a very high accurate model result, but when you apply it in actual real-time work, it will not work. And people say it's a case of overfitting and underfitting and all. In fact, that is not. So the true diagnosis of variables, the true selection of variables is very important and basically the first step in any modeling process. So here I go to briefly that what are the variable, because agriculture is very vast term. So here, the first one is multivariate analysis involves. So there are so many statistical tools involved in agriculture, statistics, and related research. And the first one is multivariate analysis that involves mainly, there are so many tools, but I focus on principal component analysis, cluster analysis, and canonical analysis to understand the interrelationship among agriculture variables. Then there are Mahalanobis D square, Hotelling T square, Wishart distribution, and the list is pretty long. The logistic modeling, logistic regression, ridge regression, nonlinear regression, and so many things. Linear regression is really speaking very less useful for real-time handling the project. So the multivariate itself have more than 100 tools for agriculture application and research. So this is just one I mentioned, but yes, these three are very important. One is principal component analysis, another is cluster analysis, and another is canonical analysis, and that three together used for interrelationship among agricultural variables. Now come to this underlying part, the variables. These variables, if you see, especially in agriculture research, is very wide. So here I start with first group. There are so many categories. The commonly used agriculture variable in Indian agriculture research and development are measurable factors used to study number one, the crop production, number two, the soil health, number three, the climatic impacts, number four, irrigation management, number five, economics and ergoeconomics, number six, sustainability and agricultural technology. These variables are used in agriculture sciences, data analytics, AI, ML, and DL part, agriculture system, remote sensing, precision farming. That's very common today and very much, in agriculture sector, people are talking about optimization to lead the precision farming. Lot of research and new techniques and algorithms are developing on how to achieve sustainable and precision farming. Then policy making for government is important, and in depth, the rural development study requires many variables. So these variables can be classified as follows. Number one, we can say the larger domain is climatic and weather related variables. For every agriculture research, a researcher need to be clear. Here, these variables affect crop growth, yield per hectare, pest control and pest occurrences related management, and water availability. So this table 1 represents variables descriptions and some common units to measure it. For example, the very first sub-variable under this category is temperature. A statistical basic exploratory calculations like finding the maximum temperature, minimum temperature, average temperature is your basic input variables. Uh, the interquartile range of temperature, the diurnal range of temperature, right? The next is rainfall, that is amount of precipitation received, and its unit is millimeter. Then humidity is another research variable that explained through the moisture present in the air. Next is solar radiations. Sunlight energy available is called solar radiation, and it is measured in watt per square meter unit. Then wind speed is important, and so speed of air, it is measured in kilometer per hour or mile per second. Then wind direction, direction of wind flow, it is measured in degree. Then evapotranspiration, water loss through evaporation plus transpiration. So as a researcher, the concrete information and measurement on these variables decide the success of your research, especially if you are a primary researcher, a field worker, then lots of laboratory work required in acquiring this measurement. But generally, this is done by a specialized investigator recruited by government and private sector. They do the survey in the field and do conduct experiment in the lab, and they are ready with this information. So most of the common academician, university researcher and professors are generally using the secondary data source available from various government and non-government sources, which I will mention you later part. So next level is, you see the in the list of variables, the next is called sunshine hours, play very important role in agriculture productivity. So what is the daily sunlight duration and how many hours per day sunlight is? Different part of country witness different intensity of sunlight because it depends upon the location, the landscape, the latitude, longitude, and our country especially is very diverse in geographical diversity. So sunshine hour is a major deciding variables in any modeling process and research. Then cloud cover, that is again an important sub variables, and that is basically the fraction of sky covered by cloud is another variables where measurement need to have and data need to be have before going for other advanced applications. So next variable in this category for weather and climatic measures is atmospheric pressure, and you can measure it in various units. Pressure ejected by atmosphere, it may be in ATP and many other units. So the question is, why? What are the role of these variables? Why these variables are important in deciding the weather and climatic measurement? Because these variables enables us to do the research on crop planning. That is your research topic, where you can use these variables and measurements and apply the various tools and techniques which you are learning through day one till now by different resource persons on AI and deep learning and machine learning applications. And there are many, deep learning site, CNN and all advanced tools are there, the RNN and CNN, and then many pre-trained models of advanced category, new models are coming also. That discussion I am not doing because it's going to be repeat, and that's why I have chosen variable as a core focus, where you as a researcher going to filter the information for pursuing your research and completing your project. So the second importance for this is drought prediction. Such kind of work you can do using these variables. If you want to do the flood forecasting, you can use these variables from listed as 1 to 10 in your model or during your modeling process. If you want to do the crop yield estimation process, where you want to estimate the crop and do the corresponding testing and validation, better utilize this variable number 1 to 10 as I listed in table 1. And then one more thing, if you want to do the climate change study, there are a lot of research happen in this field, but it does not mean the new researcher cannot go for climate change study. In research, there is no enough point. You can do a same topic but different orientation. So this is one type of variables, one categories of variables I have talked to. The second category of variables in agriculture productivity development, policy making, and research is related to the soil variables. We call it soil variables as a topic, but inside soil variable, what you need to have in your modeling. Everyone talk about machine learning and all those things and coding and Google Colab and compute. Those are calculation part, computing part, demonstration. Once you have the data, but do you have the idea that which soil variable you need to have? And here is the clue where I would like to focus for you. And then soil variables, under soil variable categories, we have basically these variables determine the soil fertility that is going to play major role for agriculture growth and development. Then another aspect is crop suitability. You cannot apply, where there is a lychee need to be cultivated, you cannot apply orange cropping there. And I think India is basically a farming country where this sense prevail in rural area better than urban people and researchers. There are many researchers who don't know the ground reality, that which types of soil texture is needed for groundnut production, and which types of soil texture is needed for cotton production. So these two variables, soil fertility and crop suitability, are going to play important role. How do you measure it? How do you do the modeling for that? These are the variables you need to get it. So again, I am giving you second table that is going to explain the needful variable or measurables needed for soil variables in modeling process. So this will be number one. The most common is soil pH value. That decides the quality of soil, where it is acidity in nature or alkalinity in nature, because crops types depends upon whether you need a acidic soil or alkaline soil. So here the second variable is soil moisture. That is the quite understood by everyone, because many of you are from agriculture background, and these are common basic term at school level. I think from 9th 10th level these variable terms are being coined, so definition is not very tough, it's very easy to underscore. The question is, yes, are you counting these variable, considering these, incorporating these variable in your research activity while developing modeling process, computing it, and getting result and preparing report? If not, there definitely you are not going to be successful in simply using mathematics and computer science and statistics in your work. So those are the tools that facilitates you, but these are the things that gives you the actual input. So here the organic carbon again is another sub-variable for soil quality and soil related research. So soil organic matter content play important role in your modeling process. Then again, this is very common. NPK ratio, nitrogen, phosphorus, and potassium content in your soil. And nitrogen is especially needed as a micronutrient for plant growth. Phosphorus is needed for root and flowering nutrient. Many agriculture expert people uh, probably know vital role of phosphorus in agriculture productivity. And my angle is to highlight you for the sake of a statistical modeling why we need these variables, and that why I am emphasizing it. Uh, I have done few papers on agriculture, and then I found after publication that I could make my paper more effective if I could have taken these variables in place of the variables selected in our model. And then I realized to okay, don't do modeling without going depth time analysis on variable selections. And that is the core focus of my today talk. So here, another important variable of soil related is electric conductivity. Generally, I have seen the paper where these variables are missing. Only some common variables are being taken, and paper has been published, and even the recommendation is done. I think that is a partial work. So electrical conductivity, a common people cannot understand its role. It will be going to be a decisive factor for salinity measurement of a soil. Then, as I said you, the soil texture, because the proper ratio of sand, these are the components of the soils, silt, clay, right? Clay composition, all these things, when in a balanced way, then that decide the soil texture. Excellent soil texture could definitely going to make the agriculture productivity far beyond expectation. So next is called the term, and the sub variable is called the bulk density. What is bulk density? Is a soil compaction level, and its measurement is needed to understand the soil quality determination, soil classification, soil clustering, hotspot identification, cold spot identification, suitability of crop cultivation. All decision could be taken based on this. So next input is that is called cation exchange, or you can say the cation label. What are the nutrient retention ability of a soil? If you have the same kind of soil with the different nutrient retention ability, and if you are using the same NPK, you are using the same design of RBD, and whatever the suitable design you are using it, you will find the productivity will be different. So cation exchange capacity play very important role in deciding the soil-based modeling process. Then micronutrients in the soil. Basically, micronutrients means a trace element in soil that is very useful, though require in the less amount, but very vital to maintain the soil health. And that is zinc, for example, some of them, there are many, iron, boron, copper, etc. Right? If their proportion is more or abysmally low, then the soil quality will be either very bad or very good. So these micronutrients measurement in your research process and their input in modeling will decide the research output. Now, today, I not focused at all on computing, algorithm, demonstration, because if I go to demonstrate in 1 hour times, I can only demonstrate any one demonstration on numerical applications or computing, and that's why I go to know. Let's will have an insight of the variables that is needed for a scientific research in agriculture productivity by every researcher depending upon their research topic. So I ask the question again, this number 1 to number 11, these subsoils, I say variables, what is the important? And why it is important in soil quality? Because this will going to help you in pursuing a research if your objective is fertility assessment for a particular region or a particular type of soil. You can do your advanced algorithms and get the fertility assessment, recommend the government, and accomplish the task. Then the next research objective is fertilizer recommendation. There is a big questions if your soil or a particular farming area requires more nitrogen or more, why you are recommending the wrong input going to directly affect adversely your output. So fertilizer recommendation system, if you want to develop for a particular region, let's say Sabari in Bhagalpur, see, very uniquely designed agriculture region, Samastipur in Bihar, the first agriculture college in India started from there. And right, so they have some particular soil content, weather conditions, and all. So what you can measure, you can focus on these variables. Then again, suppose you want to pursue a research on precision farming and you want to prepare a report or do a government project for the Bihar government or maybe the Jharkhand government or someone on precision farming, you deploy your researcher on getting these informations or measuring directly if it is possible in your lab. If you have a specialized agriculture university, then these all measurement can be done in your laboratory. But if it is a common university like engineering college, not specialized in agriculture, they need not to do that because their lab facilities hardly have these measurements. Land suitability analysis, another objective can be fulfilled using these 11 variables from 1 to 11. Now, likewise, I am moving to the next category of variables, and that comes under the crop category. We call it popularly the crop variables. And the crop variables are generally used in monitoring and yield analysis. So you must know that in agriculture, there are variety of research activity, variety of objectives. So your purpose will decide which variable, set of variable or category variables you need for your modeling process, right? So if you are interested in monitoring and yield analysis work, then you go to this category, third category of crop variables. Here, uh, what are the subvariables you need to focus? The very first subvariables under this category is crop type. What you want to, whether you want to produce rice or wheat or cotton or sugar cane, it's very important. So do the measurement according to the crop type. Then you go to crop variety and other variables in your modeling. And that could be, for example, either you go to traditional variety or nowadays there is, hardly any fruits, vegetables and agriculture crops where hybrid variety is not going to play the role, especially because of commercialization and excessive productivity objective. You see the banana itself, banana there is thousands of hybridized variety. Even in you name any agriculture product, hybridized quality. Even in rice, you see the golden rice and all. There are lot of debates on all that, and people are using hybridized variety. But yes, our traditional farmers and traditional varieties is another having a strength, right, as compared to hybrid variety. Now the next, that is the third sub variable type is germination rate. So, seed a sprouting percentage. Suppose you have 100 pieces of seeds put it in the soil on a particular cross section. What is their, how many of them and what percentage of them get sprouted? Because those who not get sprouted is the wastage. That's why the role of seed quality is very important, and that's you can how do you estimate those things in your research by keeping these variables in your modeling process. So germination rate is very important. Then you go to the plant height. Yes, crop growth indicator is used for measuring the plant height. Then leaf area index, another agriculture technical variables that is going to have measurement on photosynthetic areas, right? Then biomass, another terms as a sub variable in your model that going to play as a input, and this is total plant mass is called biomass. What is the crop yield? Another sub-variables, because production per hectare of land or area is the crop yield. Then crop duration, again another factor that decides the productivity. Some crop durations is very large, longer, and some are, for example, moong dal is a lot of harvesting happen in Bihar. I being belongs to a state Bihar, central Magad regions. In my own land, we are using productivity of mung and arhar is at very large scale. So how many days from sowing to harvesting, that is important factor in crop duration. That's why you can take it as consider it as important indispensable sub variables. So sub variables are the variables inside variable. A category of variables is the sub variable, and that is more important in any particular research than the variable itself. So another variables in agriculture productivity which is commonly used and recommended for a good research is flowering time. Reproductive stage timing is called flowering time. Then harvest index. There is a mathematical, if you go to, this is my purpose is to just give you insight. If you find out there is a particular mathematical formula for harvest index, how you can find out. This is basically the ratio of economic yield upon biological yield, right? So each of these measurables require a specific attention. And how does it help you? Why it is important? That means what I am talking here, that why these crop variables are important. I given you reason here. When you are pursuing a research and then your objective is any of these four, you go for these crop variables. What are these four? The first objective, are you pursuing a research topic where your objective is to measure the yield prediction? Then you take these variables as your input in the model. Any other things you are taking, your model is compromised, and probably you failed to diagnose why your accuracy and why
नींबू
your
तो अब बन जाएगा
precision
तुम पे
and other
लगे
things
कुछ
are
नहीं
not
बट ये
coming
है
up
अपने
to your expectation, right? So next objective in this regard, suppose you are having interested in measuring the crop health monitoring system or developing the crop health monitoring system. You can consider any of these 10 variables and all 10 variables, right? Then you go to the variety comparison objective. Which crop variety is more effective and more superior? Then again you can go to have measurement on this as a input in your model. And then the fourth one, though I have many other objective could be, but I concentrate on few important and frequently used. So if your objective is to develop agronomic experiments in your institution or in the laboratory, then again you can consider from these variables, sub variables listed 1 to 10. Now I'm switching to the another particular category, and that is called another type of variable which is used in agriculture research, especially in agriculture statistics and agriculture economics. What is this? This is called irrigation and water variables. So when you talk about irrigation and water variables, there are so many sub variables here, and this is the most frequently used sub variables list in table 4. So these variables, the very first name is called CUM, and it is irrigation frequency. Irrigation frequency means number of irrigations done in a year. Then for a particular crop. Then water table depth. What are the aquifer level in your ground table? You have heard that, when you go to Ganga plain, at some places it is just a permanent water level and aquifer level at 50 meter depth. To the other hand, at some places, even on the bank of riverside, you may have to go to 200 feet to get this water table. So water table going to play important role for irrigation management and irrigation related research process. Then water quality. How do you decide? Basically, these are the three basic term. One is pH value, another is salinity, and another is water contamination level. So these three together decides the water quality. Then next sub variable is canal water availability. There are many regions in our country where still there is no canal facilities, and you get surprised that the entire country we have to work 10 more years and even more to connect the entire agriculture zone with canal facilities. Especially in southern India, we are lacking lot of canal, maybe because of uh, Gondwana vicinity, granite vicinity, digging canal and all become very tough. And of course, it decided by whether the rivers are perennial or seasonal rivers, all right? Because canal is preferred in the regions like where that is being proliferated by perennial rivers where water is across the year, not like seasonal river like Falgu in Bihar, where my village on the bank of Falgu river we are situated. Only 1 or 2 months, but rainy season we have some water there. Remaining time no, right? So canal play very important role. Then water use efficiency, lot of water wastage because Indian citizens are particularly not being trained in school or even college. Our student teachers, even I have seen, they are wasting lot of waters while using in their domestic use or official use. So water use efficiency that is being measured through the yield per unit water is also going to be an important input in your modeling process, especially in agriculture statistics and design. Then comes soil water retention, that is water holding capacity. What is next is runoff, surface water flow. You see, nowadays there is a trend that even a 1 day complete heavy rain for 2 hours is sufficient to bring flood in Mumbai and Chennai. Why? Because due to irresponsible urbanization and poor urban designing, maybe the lack of drainage infrastructure, and of course human management, runoff is going to play a devastating role in our most of the Indian cities, especially the big cities, where even 2 or 3 days rain is sufficient to make the city flooded and the life become under trouble. So runoff management in your modeling and their particular input and measurement going to play. Then drainage rate. Again, excess water removal is going to play important role in determining the soil quality. If you are pursuing research in soil conservation, soil quality preservation, then you go to these variables. Variable number 1, sub variable 1, 2, 3, up to 8 in your modeling process. Now I am coming to the same question. Why these variables are important in irrigation and water related work? Because these are the major two objectives. If you are having, or these variables going to help us, enable us in getting the solution for drought management, getting the solution for or achieving the precision irrigation, and of course the water conservation objective. So if your research objective is these three, then my advice is you go to these variables in your modeling process and take only these data, feed your model with caution and proper information, and then apply the suitable tools. Very important, because many times what happen, you have selected the wrong data scale and you have applied those data scale on wrong tools to achieve the wrong objective. You say, I have seen this in a review paper and literature survey. If your friend and some professor have applied this technique, there blindly you also try to apply those techniques and methods without understanding the intrinsic, implicit complexities. So your objective is different, your orientation is different, your measurement should be different, your data scale should be different. Of course, then only comes your tool should be different. If somebody will apply one deep learning tool, I do not do the same thing blindly. Think on it, and that's going to help us in that way. Now, I am coming to the next level, and here that is table number 5. This table going to decide what are the variables needed for fertilizer and input related objective. So when you are pursuing a research, in one single research, you cannot do everything. So there is a big scope and opportunity for researcher, especially the computer science engineers, the mathematician, and a statistician, to pursue research in the field of agriculture in the name of multidisciplinary research that the entire world is thriving on. You have seen the research output of institution is going exponentially high. Our own institution, VIT, Vellore Institute of Technology, is a sixth rank research institute as on today, where 80% of the research output is multidisciplinary, collaborative, and application oriented. If you see the basic research, the proportion is very disappointing, very less. And the same is I have found in most of the other institution and research institution, right? So here, next level we'll go to this fertilizer input variables. I think this is useful and very useful for those students, researcher, and faculty members who is not from agriculture background, but of course it is going to give a good insight even those who belongs to agriculture as their profession, or maybe the student of agriculture sciences and technology pursuing UG and PG. This is also very important for them. So here the this talk you have find is totally different what's going on into the previous sessions, because most of the session which I have attended as a student also in this particular ongoing 5-day STP, I myself is a my role is as a student and participant also, and I am very happy that there is a rich wide range of resource person giving different demonstration. So Saturday night I have changed the mind. And why? Because if I do the same CNN and other demonstration, that is quite boring for the audience. And that's why in the whole night yesterday, I developed my this thought and come to the focus on the variable and related part, which was I have seen no resource person have given focus on this till now. And that's my motivation to discuss this all variables in very extensive manner. So here the first sub variable is fertilizer quality. Very important. Lot of adulations are there. If you are using Chinese fertilizer, if you are using the indigenous fertilizer, organic fertilizer, the impact on productivity and their side effect on your consumptions is very decisive. Then pesticide, again a huge business, huge economy, because the agriculture range, agriculture people, especially I'm talking our own country, Still more than 50% people rely on agriculture. Though their national contribution in GDP and GNP is less now, but the number of people employed in agriculture sector is still very high in India, because basically we have been agrarian economy gradually shifting. In last 10 years we have been shifted a lot, and hopefully in next 10 years we would be the leader in service sector in the world. But let's hope so. We should also be leader in the agriculture productivity and services by using high technology without compromising on our traditional strength, which our farmers, even though not having the formal education, but they are very experienced, and on the ground they are much more trained than many agriculture scientists. So here, herbicide, again, the weed control and related chemicals. That will be, these are all caution points. For a researcher, is very good insight that where do you use, if you use these variables in your work, definitely you are going to bring a very remarkable output to your government and to your society. Then seed rate, you do quantity of seeds sown, and a lot of research is, especially the specialized agriculture scientists have done lot of research. Mathematician have not done. It's not the role of mathematician. It's not the role of a statistician and computer science paper. It is the role of domain expert. But once you work on it with collaboration with the domain expert, you can bring a fantastic output, very useful both for you and you're the domain expert, and that's why collaboration needed. So here, machinery usage again going to be a decisive factor. Tractor and high advanced equipment, you have seen the Punjab agriculture, and the number of tractors density in Punjab is far more superior than Bihar and other part of the states, and that leads the Punjab as a agrarian economy, and their contribution is very high. So labor requirement, again another sub variables going to be a very important play role play, and the strength of our state and bigger state like UP, Bihar and all, the labor requirement is there and labor is available there. So human workforce needed, and to be included in your modeling process, their side effect and their benefits both are going to be assessed in a good research output. Then biofertilizer usage. Do we have the organic microbial inputs? Yes, then fine, go for modeling it. If no, then find out why not. So organic microbial input is going to decide the quality agriculture productivity, right? And then again, I have asked the same question: why these 1 to 7 number sub variables required? Which kind of research will do where this requires? So here, our importance of these variables is number one, when you are doing the cost analysis, because you see all these are cost oriented. Labor requirement cost oriented, organic microbial inputs and biofertilizer cost oriented, machinery cost oriented, seed quality, seed rate and seed purchase, lot of cost involved, right? Then herbicide applications, herbicide is costly item, pesticide costly item, fertilizer costly item. You see the government subsidy in fertilizer, right? Because we are largely depending upon the fertilizer productivity is still less in country as our demand. So we depend upon fertilizer input from country like China and many more. So that's why you have seen the common things all are cost oriented, and therefore our this measurement going to help us in pursuing a research when our core focus is on cost analysis. Then the second benefit, second type of research where we going to benefit by these 7 inputs in our modeling process is sustainable agriculture growth. And then because you see now, these all are bringing the side effect. And when side effects are there, sustainability is a question. We want eco-friendly agriculture. We want sustainable agriculture. Agriculture where productivity is high but disaster or side effect is minimum. Because that have the future, right? And then if you are having the third category research objective like productivity optimization, fine, that's very important. So when you are using the CNN and RNN blindly using Adam and using softmax and using other things as a optimizer, that not going to work here. Whether you are choosing these variables in your input or not, that going to decide. The tools not going to decide. Tools will do just processing and generate the output. But if input is superb, output is definitely going to be computational efficiency going to be manipulated. But the efficiency of the actual research, real research, will decide by these inputs. So you should be very cautious in selecting the inputs. And that is the core focus of my today talk. Because there are different orientations and that cannot be possible to cover in 1 or 2 hour sessions. And of course, the tools are being already demonstrated. You have seen the Python demonstration. I have seen, I thought of demonstrating R software, but I thought demonstrating one important thing is not so useful as compared to giving the panorama of these variables to you, so that when you do the research, you take care of this as the input and it inculcate idea in your mind, right? So once you are very clear in research and variable input, you should definitely not going to commit mistake in methodology, algorithms, model selection, and post-model analytics. So here, the sixth category, and the sixth category is economic variable. You see, I have given the name based on sub-variables. Now you will see all these sub-variables from 1 to 10 here will lead to direct linkage with economic variables, and that's why we can say it is economic variable. Let's say first, cost of cultivation. Total farming expenditure is called cost of cultivation. Very decisive factor for the happiness of the farmer. You've seen many people, you say, when you are working in a city and your brother is working in your traditional land, most of the time you talk that, yeah, my brother income, I don't know, lot of, I have 100-acre land or 50-acre land, what he is doing. My dear friend, if you are earning in city and you don't able to save, how can you can expect that your brother working in agriculture will able to save? Because cost of cultivation is rising, and exponentially rising. You see, the Western Middle East disturbance is going to increase the cost of cultivation, and Prime Minister appeal 1 or 2 days before, all is highly meaningful, and we must respect the sentiment of our leaders. We must obey that, because if you're not sensible enough, you cannot help your country. Then gross return, again, total income from crop, right? Means after deducting, this gross return, if you deduct the cost of cultivation from gross return, then you get net profit. And this profit decide the farmer quality, the life standard, and their happiness. Total farming alone not, total income alone not, and net profit play very important. Indian economy is still, especially I'm talking to agriculture economy, is still a character of vagaries, monsoonal vagaries. You cannot say that what's going to happen during rainy season. Is it drought or is it over rain? And that is the traditional challenge to our. We are going to improve. We are doing a hard work. We are putting efforts, but still we need to discuss it. And it's a global problem also. Not only in our country, the level of this problem, intensity of this problem may differ country to country, and even inside the country there is a complete heterogeneity in distribution of these vagaries. So now you see, net all are economic term, and that's why the name of this is economic variables. So here you can measure and develop a market price in your model. You must take value on market price. Then selling price is called the market price. Minimum support price, MSP, play important role. Farm size, yes, very important and crucial factor nowadays. Throughout the country, the large farm size is missing. Earlier, when I was child, in my own house, the land size was in biga, 2 biga, 4 biga, 3 biga, 1 acre, 2 acre. Now in kattha, right? Not in kila, in Haryana, small decimals, right? Because family is getting nuclei, division of land is happening, so farm size is reducing. When your farm size is reducing, productivity is bound to suffer, and input on your production is likely to be high. So land holding area is very important input in agriculture research and project. Then labor cost, you see that labor cost is how important. I need not to talk on that. The wage expenditure, the labor cost, everything is going to be changed. And because low labor cost in Orissa, Jharkhand, Bihar, Uttar Pradesh, part of Madhya Pradesh, Chhattisgarh, West Bengal, all these, what is the positive factor there? Why industry settlement are there? Why all, in the during the second Indian plan, why all heavy industry is being invested in those areas? The so-called Great Mineral Belt of India. All steel plant from Rourkela to Bokaro to Durgapur, all are in labor intensive because those are labor intensive. So labor cost going to play very important role. And then credit availability, agriculture loans going to play important role. You see, I have a paper published on Maharashtra Society, Farmer Society, and the reasons and pros and cons, and where the credit availability is a single factor that going to decide the suicide rate, right? In Tamil Nadu as well as in Maharashtra, these are the two states where highest suicide, farming suicide cases are being as per our NCRB records, right? So credit availability going to play important role, and government is doing the best, but still we need to do a lot of things. So in your research and modeling process, are you taking credit availability as a input variable or not? You think on it. Then you go to insurance coverage, and you see the current government have given lot of focus on insurance coverage. Still in country, if you see the UK farming insurance coverage, you see the American farming, Japanese farming, Israelis farming, and compare with insurance coverage of Indian farming, the gap is very high, abysmal gap, is a fraction. Still we are suffering from a hardly 20% level, and they are on 80 plus, 90 plus, some country even 96% and 100% close to that. So the input cost, again the next sub variable, fertilizer input, seed input, pesticide input cost, all are uncontrolled, or if controlled, then government is having lot of subsidy, and of course it load is on governance or government expenditure is very high. So the role of common people and the role of farmers, and especially the wealthy farmers and the middleman, all are going to play, and their honesty going to play a decisive role in agriculture productivity. Now another category comes. So why? Again the similar question. What are the important of these economic variables in agriculture productivity? Of course, these four, right? So the first one is agriculture economics and policy research. If you want to do this research as a paper, as a project, go for these variables in your work and do all calculation only on this. Other variables should be out of your modeling process, all right? Otherwise, unnecessary, you are creating a standard error in your model, you are overfitting the model, your estimate will be bound to suffer, and your decision is bound to suffer. Does not matter what machine accuracy. And many research scholars, so sir, my model is giving 96%, and they're very happy. हमने कहा okay, come, 96% accuracy. But what is your input variable in your model? How you have fitted the model? Have you done the variable selection with a proper mindset? Answer is big no. Simply because they read some research paper, they follow the same variable and implement it in their work, solve some mathematics and a statistics, get some automation, Python and others, and come up with the research. This is not at all research. In fact, this is a fraudism, research manipulations. So you need to have these variables measurements. You master yourself. You will be process, do the enough data processing, find the outliers, found the influential factors, found the Z-score computations, apply the normalization, apply the general variability measurement, go for clustering before doing actual implementations. Identify the do the box plot and all, and try identify how many outliers are there. Do the outliers are needful, not needful, useful, harmful? All those things you need to do. Research is not a objective process. It's a complete 8 stage research methodology. Start from planning stage to problem definition to field work, means data retrieval, then field survey, like different types of sampling, stratified sampling, random sampling, Hurwitz-Thompson sampling, and all those things. Then go to designing, plotting, which kind of research design is it, experimental research, quasi experimental research, or is organizational research. Then you go to the methodology, which kind of methodology you are going to set. Then you go inside methodology, lot of process and things are there. You have to do the inference, you have to do the comparison, you have to build the model, you have to find out the result, you develop the relations. Some relations are linear, some relations are non-linear. All those discussions and comprehensive knowledge you need to develop as a researcher, and most of the good researchers are really mastering it. But it's a lifelong learning. You cannot say that today I am 56-year-old, it means I am a wonderful researcher. Does not matter if you have 1,000 publication. You need to be very cautious in 1,001 publication and apply the same causes in your research. Then only the quality research will come. Otherwise, number could be there, the quality could not be there. Especially I'm talking today for research and agriculture research activity for development purpose. So why these economic variables? How does it help you? Yes, it's going to help you in that way. Number one, it's going to be used for agriculture economics and policy research. It's going to be used for your farm profitability, right? And then you see today there is a trend that many young researcher or industry person working at a good package in America, they come back to Karnataka and do some agriculture activity and become a very good exporter of raspberry and all. Lot of case study I have gone through, right? That means we have to use the farm profitability technique and complete advancements of new technology, proper meteorological study and surveillance, all modern equipment implication. So the technology agriculture is the future for any country, and we are also moving to that. So government policy formulation and rural economic development, all four things can be decided by these 9 variables which I have mentioned in this particular table. Next level, I think next 10 minutes I will exhaust this discussion. But now you are aware, I think many of you never thought that so many intrinsic variables are really needed to give a focus in pursuing research activity, especially on agriculture. Because today I have not focused on biomedical engineering, because in that case I have decided it become impossible for me to cover those genetic statistics and biomedical statistics in this 1 hour session. So I chosen very one particular agriculture sector upon which only one segment, and that is variable selection. That is the purpose of this particular 1 hour utilization. So next level is called remote sensing and GIS variable. Another category, again you see there are so many variable inside it, right? And remote sensing and GIS is very important today. You see the Prime Minister drone survey of agriculture land. Basically, it is based on remote sensing technique and GIS variable, geographical information system area. So here, what is the core sub variables? Those specialized agriculture people and students and professors here aware, but what about others? I think the common researcher even don't know the term NDVI, normalized difference vegetation index. That is being though it not need not, because I won't like to go to mathematics today, and that's why I have deviated from all tool oriented and demonstration. Just I want to make it a kind of informative work today, and that's why so NDVI is very important, where we do this ratio, and this ratio is NIR minus rate upon NIR plus rate. In fact, it is a relative measurement, relative coefficient. It is a ratio of two, right? So for a comparison, relative coefficient are very important. Its range varies from -1 to 1. And when you have less than zero value for this NDVI, it shows negative value shows the prevalence of water, snow, cloud, and the land is not cultivable. So the negative agriculture is there. When your value, this value of NDVI varies between 0 and 0.1, you can say the land is barren. Most of the two-thirds of Indian soil still comes under this category, where potential is there, but it remain barren. It might belongs to Telangana water drought area, to the Rajasthan, to Madhya Pradesh, and many more. Still in India, the drought prone area is two-thirds, and only one-third land is not drought prone. Then NIR stand for near infrared reflectant. It's another measure, and RED stand for red band reflectance, right? So these are the technical measurement required to be done in the laboratory, and which is available in a most of the website. I would mention it after a few minutes, right? Where these informations are all documented nicely. For a researcher, you go there, you filter the information, take from various portals, and do the agriculture related research more authentically, more comprehensively, and more precisely. Now I came to this part. So as I said you, this is just one sub variable NDVI. How we calculate, I have given the range of NDVI decides which kind of agriculture. So when it is 0 to 0.1, it is bare soil land and rocks and all. When it varies between 0.2 to 0.5, we call it a sparse vegetation, means okay, like some jaw and millet and all those things are there. 0.6 to 0.9 means dense health vegetation, rice cultivation, wheat cultivation, and other kharif and rabi cultivation will happen. So this is a star factor. India needs this one more. Unfortunately, under this category, we are witnessing only our 20% of agriculture land. Rest 80% not comes under this category. That is the concern and challenges to us as of today. And here is the opportunity of our researcher, how we can guide our government and common people to make these range available for majority of the Indian lands, especially the farming lands. Right? Now, the next technical term under this variable is EVI, Enhanced Vegetation Index. Again, this requires a measurement. I don't go for how we measure it, but the agriculture domain people know it well, and they do in laboratory. So it is used for vegetation index at further advanced stage. So this is basically upgradation of this variable NDVI. So NDVI, now EVI is better option, and then land surface temperature measurement is needed. So surface heat measurement is very important. You go accordingly and then take a decision what kind of crops you want, what timing you want, how what are the intensity of agriculture you want, and what are the combination of cropping with other vegetation like horticulture and other cultures you want. That you can decide based on the surface land temperatures. Now soil moisture condition or index again going to play very important role. So moisture from satellite data is easily measurable today, and that is a great relief to the researcher. Without measuring, they can easily get from the website of the government and important organization which I mentioned below. Then vegetation cover, you can do the crop density, land use, land cover input is very important as a sub variable for agricultural land mapping. Then GPS coordination required, where the field location in terms of latitude and longitude play important decisive role. And another sub variable is called elevation, that is the height above sea level, that generally people ignore in agriculture research. But please understand, you take a Himalaya, if you go to Himachal Pradesh, the lower Himalaya, middle Himalaya, upper Himalaya, and you see the vegetation types is varies. It's not because of variation in temperature only, because elevation is a decisive factor. If you go to higher height, the pressure condition, the moisture condition, the temperature condition, and that's why you see the vegetation, flora and fauna on lower Himalaya is different than middle Himalaya, and vertical variations are there. So elevation is as a research input, as a variable, going to make a very decisive role in your good quality research. Ultimately, when we talk about this sub variable from 1 to 8 up to elevation, and we call it which variable? We call it the category of uh, remote sensing and GIS variable. How it is important and what importance it is. This is important for this reason. Number one, for satellite crop monitoring research, these variables you need to focus. For precision agriculture and optimization of agriculture, you need these variables. For yield forecasting optimization problem, you can need these variables. And for a disaster assessment, especially when post earthquake or calamities happen, or ocean storm and all those things happen, wind storm happen, then disaster assessment requires these variables and sub variables in your research output. So I have given you almost a comprehensive list of all categories that is usually a different type of researchers, especially the agriculture scientists and all, are using in different situation for different research. Now I think it is the third last category, that is the eighth category, pest and disease variable. Right? So under this, again, there are so many variables, and for every variables, measurement is either available as a secondary source, or if not, then your researcher need to measure it in your laboratory or in the field. Right? So pest population density, number of pests per square unit of area. Then disease severity, very important. Most of you are talking about CNN and all, right? Where image processing is done for disease control. You see the leaf of a plant and take the image, and then you can diagnose whether this plant is suffering from this particular disease or not, or what proportion and what are the level. So this is one task. Here you can apply the CNN and all. So the disease severity means the proportion of infection percentage in a particular plant or particular leaf. Then infestation rate, another important sub variable, that means pest attack frequency, that is called infestation rate. If pest attack frequency is very high, you have to think seriously on that. If it is moderate, if it is low, accordingly you have to design the model. And then pesticide resistance. So as a mathematician and a statistician and computer science people or AI expert, you need to know all these things. Merely doing this computation is not going to make you a smart researcher. And for that, you have to collaborate with a domain expert. It does not mean you should not have basic elementary knowledge of agriculture. And that's why I request each one of you that you decide, I will do 5 year a specific agriculture related research, next 5 year fishery related research, next 5 year. So you just decide your research domain. Don't enter into today you are doing criminology research, tomorrow you are doing research on non-social activity, and day after tomorrow you are going to handle the research on share stocks market and all. I think that will not going to make you an expert researcher. So be a domain specific researcher, and that way you need to learn those domain as a subsidiary knowledge. And then this is the purpose to highlight these things to you. So crop damage percentage, that is called yield loss estimate. Unless until you don't have the crop damage percentage, how do you going to give the return to the farmer? And post calamity, this objective I said na, disaster assessment, how do you do that? Because you need to have this yield loss estimate as an input, then only you can develop this policy and planning and recommending your paper to the government and other stakeholders. So ultimately, these pest and disease variables, why important? How does it going to help you? It's going to enable these four objectives to achieve these four objectives of your research. Number one, it is used for crop protection research. It is used for pest prediction system. It is going to be disease management and disease detection, that you see most of the frequent young researchers are doing it. I am doing disease research, whether it is a human disease or plant disease, but they are working on that. And I have seen sessions in heart disease and others already taken place yesterday by some IIT professor, Mrs. Saha or someone. So AI-based crop diagnosis, right? All these things are very important, but please take care. For that, you need these inputs in your research, and that is pest and disease variable going to play important role. Now, the next is called another section of agriculture, again very important, and their remarkable contribution in agriculture sector as economic growth. That is called livestock variable. That because they are going to generate livestock economy. So very useful for mixed kind of farming where agriculture is pursued in association with livestock, rearing the animals and getting benefits out of it. So this farming system is again going to be very useful for modern economy as agriculture. So what are the sub variable here you need? Here you need to measure the milk yield, information on milk yield, right? Information on feed consumption, feed intake time, then animal weight, body mass of the animal, then mortality rate of animal, then reproductive rate of animals. And that's why you see in rare stocks and livestock, when you take a decision, got rearing or maybe other cow rearing, all these will be taken as important parameters. All right. And then they do pursue. So breeding efficiency, death percentage, body mass, feed intake, milk production, all going to play important decisive role when you fulfill the objective of this kind of research, livestock contribution and related research in agriculture productivity. Next, the 10th category is socio-economic and demographic variables category of agriculture productivity. Here is going to used as a rural development and policy research. So here we call the name this variable as socio-economic and demographic research, because especially in technical demography, that's a I think if some of you belongs to a statistics domain, you must be very familiar with technical demography. Is a vast area where a lot of population research to social research, immigrant, immigration, and all those things. We are working on growth model, Pareto model, Gumper's model, and so many models are there, right? So the technical demography going to decide a future of our research, especially related to human congestion and this illegal immigrant problems in India, especially in West Bengal and all, Northeast and all. So here you see the socio-economic and demographic variables. The variables comes under these subcategories. I have listed it from 1 to 6. The very first is farmer education level, very important role. Farmer must be literate, or if not, must be trained by government and some voluntary organization, because nowadays farming should be a technical work. It should not be non-technical, otherwise that farmer has to do the suicide, right? So if you want to control the suicide rate among farmers, you make your farmers productive, lucrative, and it is only possible through farmer education level, literacy level, training level, land ownership. Again, a very disputable, most of the disputes in Indian civil courts are related to land. And that's why drone survey concept comes to Prime Minister mind. And who owned the land, or you are doing the cultivation on leased land, that's going to decide your profitability. So your input on land ownership is very important in pursuing the research. family size going to play matters, household members how many, adoption of technology, are you a farmer with full technological innovations or experimentation, or you a farmer going to traditional route only, that decide the productivity of agriculture. So usage of modern methods are highly recommended. Then access to the market, yes, your farming is near to the market or not. Second thing, what are the government marketing policy for the farmer? Recently you have seen the changes. Government want to empower each farmer that you can product your steps and directly sell to international market. So that would be a great opportunity that if we have farmer allowed to sell their product into Dubai market directly without middleman, and that's why access to the market is going to play an important role in future of farming return in India. And then internet availability, which almost we have achieved, almost entire villages even in rural areas are being connected by optical fiber throughout the country. So we are expecting a great development in remaining 5 to 10 years. Indian economy and especially the agriculture economy is going to be exponentially exaggerated. And then comes the last category, that is called sustainability and environmental variables, very important part of our agriculture productivity and growth. Here the climate smart agriculture is needed, and for that I have determined, though some minor factors I have ignored in the list, but these are the key factors. One is carbon emission, another is biodiversity index, another is soil erosion rate, water footprint, and energy consumption. So when you go to the greenhouse gas release, when you go to the specified diversities, a species diversity, you have to go to the land degradation concept, and then water consumption and fuel electricity usage and their efficiency definitely is going to help you to increase your agriculture productivity. And then the most important variables in Indian agriculture. Now, I would like to say, just as a summary of this, because there are more than 100 variables already I have listed under category 1 to category 11. But in pursuing a common research, of course, you go a specific objective with objective specific selection of variable. But I have given you a commonly used variables in your modern modeling process, especially in artificial intelligence and all. One is rainfall, another is temperature, which most of the common researchers do, soil moisture, soil pH, NPK ratio, crop yield, irrigation availability, fertilizer usage, NDVI index, EVI index, you can put it also here because that is more advanced. Then market price, pest incidence, land holding size, groundwater level, humidity, especially relative humidity, and crop variety. Diversity of crop is going to give lot of profitability or losses to uh, depends upon decision of the farming and timing of the decision. Then the next few things which I like to highlight is here, because this particular STP is machine learning and deep learning focused on agriculture and bioengineering. So I have just, for that point of view, I have just mentioned a small information here. Finally, we explore the variables used for our AI, ML, and deep learning based agriculture project and research. So here, especially though I have covered, but I especially mention here for you that you must be, because this particular STP is AI and deep learning oriented and centric. So I say, okay, for this, these are the sub variables you frequently use in your research paper, research project. Number one, crop yield prediction may be done through the rainfall, the temperature, the soil, the nutrients, irrigation. If you go to disease detection, then you go to the leaf images, CNN and all, you can use humidity, relative humidity, temperature, right? If you want to go for soil classification problem in your research, then go to the soil quality like pH, EC, NPK, texture, soil texture and all. If your research of objective is price prediction related, then go to the market arrivals, demand conditions, the weather conditions. If you want a smart irrigation project, then go to take the filter the input on soil moisture related variable and some variable. extra evapotranspiration related variable. And then if your objective is weather forecasting, you can go to historical climate variable. And with that, I stop on this variable portion, and I'll take 1 or 2 minute maximum more to have some additional subsidiary information to share. So the next point, at the point number 14, I mentioned some of the Indian government data sources that is commonly openly publicly available for you people to pursue your research, and you can go to comfortably retrieve the information from there. That is especially for agriculture variables, agriculture statistics, and agriculture researcher. Those who are from agriculture background, they already know it, but those who are non-agriculture background, I think you will find it very useful. That following are the useful data sets and organization. I have not mentioned all, just few, which is commonly utilized organization for preserving the research activity. Number one, the top is of course very popular, Indian Council of Agriculture Research. You go there on their web portals, a lot of data reservoirs are there, data warehouses are there. You can retrieve from there. Some of them are open, some of them requires approval, some of them require some special process. You are open to go for that for your research activity. I used to send my student to ICR for that purpose. Maybe in here Chennai branch is there, so ICR have a different center across the country, and you can send your researcher any center, and they can collect information, especially some specific information that is not available in public domain. They would be very helpful people, and their policy is very supportive to the researcher. Then Ministry of Agriculture and Farmer Welfare, another data source. You can go there and take a lot of information for your research activity. Then you go to the third source, that is Indian Meteorological Department, IMD. Again here some are very live data are there, and some data need to be get approval, and through a process you can retrieve from officials there. Some of them are paid, some of them are unpaid, so you can have a tremendous choices. Then the next one is NABARD, very common organization that is called National Bank for Agriculture and Rural Development, that provide you lot of information, especially on agriculture economy, and especially on the profit oriented, economic oriented research. You can go for NABARD data and rely on it. Then agriculture statistics at a glance is a bulletin published from the ICR, and then this is a FAO stat, that's a another data portal from where a lot of information can be taken, and this is very commonly used, but bad quality data there I cannot suggest. Kaggle agriculture data set for a school and college learner is okay, but for actual implementation and project I
Hello,
do not suggest it,
sir.
because it's a bad data and irresponsible data are there. Yes, for learning and processing and demonstration, Kaggle can be used, but for real research, I do not suggest anybody should use Kaggle data for agriculture data set or in other data set, right? Because we cannot
Sir,
authenticate it in
sorry
that.
to interrupt you. Sir,
Yes,
sorry to
sir.
interrupt you. Yeah, so we do have other sessions also. We do have lunch time.
It's
So,
going to 1 minute, sir.
sir, you can wrap it in 5 minutes. You can take 5 minutes and wrap it if it's okay.
Yes, yes, sir. I think
Okay.
I have already arrived at conclusion part. So
Okay, sir.
here you
Sure, sure.
see the conclusion, what I have discussed in last 1 hour. Probably I take in your mind to the frame on a minute element, and that is only on focus on variables. That is the raw material for research. I have not discussed today anything else. No methods, no time series taking, lot of things in time series that we get some opportunity to discuss sometimes in future on a specific task. But today my objective is only on one element. For every research, the soul is input, and that input comes through retrieval of variables. Decision of parameters will decided also through the variables and sub-variables, and I highlighted especially in agriculture related. So agriculture research in India uses multi-dimensional variables covering climate, soil, crop growth, water management, economics, ergoeconomics, remote sensing, pest management, sustainability, farmer socio-economic condition like suicide, farmer suicide and all, and then I say these are the variables essential for this work. I say precision agriculture, climate smart farming, AI, ML and DL crop predictions, a smart irrigation system, agriculture policy planning, sustainable rural development. Of course, these are the input for the AI and all. I don't know that is it the same input we need for quantum computing, because that's going to be a future in revolutionary computing with revolutionary computing power. So I hope and wish that these variables, input variables, the raw materials, and the the sub variables going to play important role in even quantum processing and quantum technology. Their relevant will no longer going to be waste, right? Yes, processing process and speed will change. So anyway, that's we will see in future. And next a few 1 minute, because I have 2 3 minutes, so that's I want to say to is before say the mixed model and a spatial analysis you can do in agriculture. How you can do it? You can use multi-environmental trial analysis. Particularly, I'm talking about agriculture statistics point of view. So the linear mixed model is very useful and commonly used today. So some of the methods I just want to mention now, because variables I have done through. So what are the common methods? Though all is not, but some are very popular I would like to, and some of the software I would like to mention in 1 minute. So LMM, linear mixed model, is going to be very useful for mixed model and spatial analysis. Then for artificial intelligence, ML and DL, of course, you are aware with that applied for predictive analytics, such as crop yield prediction based on morphological characters, pest forecasting, or forewarning and disease detection. You can go for AI and related domain. Then Bayesian approach is recommended also, which is very powerful, very useful statistical tools, having full of flexibility and very wide application of prior probability. So this is used for forecasting and in a specialized study where the prior knowledge is integrated, including the Bayesian time series modeling and detailed discussion. I have not we will done, because each STP have one session on each tool. So that's why, but I would like to put in your brain that yes, the time series modeling, again, I want to deliver complete topic today on this one, but I gone through that. If I not go through the variables, it would be injustice to directly talk on time series modeling and giving some demonstration. Especially in time series modeling, I have a very recent, the new pattern and very lucrative, good quality research is coming through this one. That is called wavelet techniques applied in time series, and that is wavelet long memory technique, a complete revolutionary change in frequency time series analysis that we will discuss sometimes in future if we got opportunity like this. Then genomic selection and GWAS, that's very important, and there are the advanced technique in plant breeding, but this is especially used for plant breeding research, and especially when you are analyzing the genotype and phenotype of data. If you are not analyzing genotype and phenotype data, then genomic selection and GWS does not require to you. Then you go to the spatial statistics and GIS. You are aware with that GIS, and wherever a spatial data is there, you can utilize this remote sensing activity and all that is under use in the current government. And we are going to monitor the soil health, crop health. We are using GIS, we are using a spatial data set. Then scan statistics, I think in India, I do not find before my own PhD in on scan statistics from Patna University. Only one Indian government ISS officer, Mr. Pankaj Srivastav, 1 year junior to me in Hindu College, Delhi University, have gone through the scan statistics under same guide. Professor Arun Kumar Sinha, the retired Vice Chancellor of Patna University, we have been the first one to apply scan stats in India. Especially I have applied in criminology, and Pankaj has applied in epidemiology, right? Kalajar cases in India analysis, especially in Bihar, the Hajipur district and all. And then we'll go to the advanced statistical tool software. Some of the Q name, which you already familiar, no need to do, but I just take 1 minute. R programming, widely used comprehensive software, especially for a statistical purpose, very useful for agriculture data, and we can use it, we can demonstrate it. And some special package development like boot mrmr is very popular in Europe. Then GSAC is again another package developed using the R. Then SAS, statistical analysis software, is a heavy software and most complex analysis software, but very powerful. And no other software could compete with SAS, but it's costly and it's difficult to learn, and that's why it is not so popular for common people. And then you go to ASRME-R and ASRME-SA. These are the specialized software for fitting complex linear model. Then GenStat is very popular, is a comprehensive statistical software package, especially for development of agriculture researchers and breeders. Then a star is very popular in India nowadays as a statistical tool for agriculture research, a user-friendly tool for design and analysis of experimental data, design of experiment, particularly useful for non-statistician even. Those even don't have the idea of a statistic can go with a star application. And then Python, of course, everyone is familiar with that. And then this is site design, that is another popular software used for the agriculture sector, a specialized software effective for designing optimal experimentation process. And then key area of agriculture research, I say crop improvement, forecasting and modeling, resource management. Any one of you can go to any particular field, and maybe you have already done. Then livestock fisher farming, then economy and policy related things, and this technology are documented well. All these discussions which I have done, you can find it in ICR publication or annual report of Indian Agriculture Statistical Research Institute, Pusha, Delhi. And these are the recent things which you can apply in your research. With that, I take your permission because maybe I have crossed the time, and for that I really feel sorry about it. Allow me to stop here. If anyone have some queries or want to put some point, you are most welcome. Thank you so much.
Thank you so much, sir. Yeah. So thank you so much, sir. With this, I would like to thank the speaker, Dr. Jitendra Kumar, sir, for such enlightening and engaging lecture. Your presentation gave us meaningful insights into various aspects of agricultural research, particularly about selecting the right variables for the problems before modeling, and focusing on the selection of variables, not just focusing on the modeling aspect. Okay, so we deeply appreciate your effort in delivering such a meaningful and knowledge-rich session. Thank you, sir. And I want you to stop sharing your screen so that we can take a photo with
Yes,
you. If possible.
yes, sir, yes, sir. Just
We would like to take a photo with you, sir.
Okay, sir.
Yeah.
Just a minute. I'll try to stop. Stop. I have stopped, sir.
Yes, sir. We are taking a photo. Give us 1 minute. Yeah. Thank you, sir. We have taken the photo. Thank you.
Thank you so much. Thank you so much for patience sharing.
Thank
All
you,
right.
sir. Yeah. So we'll all be breaking for lunch, and we'll meet at 3:25 for the next lecture.
Thank you, sir.
Thank you, sir. Thank you.